Hello, everyone. My name is Amir Rozenberg, and I'm Director of Product Management here at Perfecto Mobile. And I'm very excited to join this Neotis exciting virtual summit on performance testing. And the topic for today that I'd like to discuss is shifting left performance testing. And essentially, one of the things that we're seeing in terms of performance testing, unfortunately, is discovering late on launch day or close to launch day that there are all kinds of performance issues, and at that point in time, you come to a decision whether you want to take the risk of going out with suboptimal performance for your application, or alternatively, postpone the launch and suffer from time to market consequences. So diving into the talk, what we're going to talk today is what's changing in the process of software development that is impacting performance testing and performance engineering. And as a result of that, what is appropriate to shift left? What are the tools? What are the methodologies that are available? And we're going to conclude with a demo of these methodologies and tools that I'm going to mention. So firstly, I think it's helpful to take a step back and take a look at what's changing in terms of software development and performance engineering. And I think one of the big trends that are changing everything around us is really digital transformation. And I know this word is being, digital transformation is being used so often in so many contexts that it's really sometimes confusing to think about digital transformation. But what it really means from my perspective is really an expansion of digital interfaces that touch our end users, whether it's a B2B or B2C environment, on an enhanced, expanded number of screens and types of screens, desktop web, mobile phones, tablets, things in between, and now we're seeing new interfaces showing up in all kinds of IoT devices, in vehicle screens, or even Fire TV has applications that you can download and interact with. Also, from a sensor perspective, there are all kinds of ways to streamline and enrich experiences, as you can see to the bottom right, a dinosaur in the middle of a basketball court. But really, in truth, there's really enrichment of experiences, and what that means for the team lead is that the scope of their deliverable is really expanding tremendously. There's a lot of pressure to differentiate through new features and new screens that the brand is present on. There's, of course, even further pressure to be present in front of the competition, to lead the market in the respective verticals. And so from a team lead perspective, people are trying to better define what is the minimal viable product and what is how can I get to market faster. And what that means typically is that people are moving into agile methodology, sprints are shrinking all the way even to the extreme of continuous deployment. But what that means from a team lead perspective is that sometimes quality gives, and that's a real problem. Because you find yourself at the end of the sprint, we're going to talk about it in a second, where you've completed development, it's up to scope, you were able to shave a week off of your sprint, but you don't know the quality, and that's when you start your testing. And that just means that if something's flaky or you're going to find a bug, you're going to have to, and it's not small, you're going to have either to delay the sprint, the launch, or you're going to have to go out with risk. And so I think that's one big change that's happening in the software development space. The other change that's really materially changing from a performance testing perspective is that the power presented on the client side, whether you think about sensor and caching access for HTML5 or the sensors and computing power even on mobile phones, there's really quite a lot that's happening on the client side. And so the traditional practice of testing the servers and the load balancers and the delivery chain through service APIs for responsiveness at the end user perspective, that really needs to change somewhat, because now the client side is playing a substantial part in in the end user experience. And so, kind of moving to the next challenge, we're seeing engineering squads, engineering teams adopting frequent testing methodologies in order to avoid what's called the big bang, what we call the big bang. And what you can see to the bottom left is 3 lines of software trees in your repository, for example, and different teams represented, or different features represented by the green, blue, and orange. And when you have infrequent integration efforts, what you end up happening is at the end of the sprint, around here, things don't connect. And when things don't connect, you need to re-engineer everything. So you have to push out your launch date, and now you're doing testing and everything is delayed. And essentially, what we're saying is, to the bottom right, do recurring integrations, frequent integrations, and frequent testing. And really, this talk is all about performance testing, adding performance testing to your automation so it happens frequently, and you don't find, performance issues when it's time to launch. And the other interesting thing that I'm seeing in the marketplace is that a lot of developers are now participating actively in testing, in engineering and testing of what's called performance budgets. Definitely, it's something that's happening. People are more aware and are participating, which is really great. So, like we said, developers are increasingly becoming aware of budget, but the question becomes, when you say the word performance testing, does that equate to load testing? So, and what happens to developer? Can you do something about it? So the question is, and no pun to anyone, I know this topic is a little bit in controversy, but the question that I'm asking myself is, can development environments sustain load, the traditional performance testing, so the developers can run a load test? Can you run load testing per commit or per smoke test or regression test? Does it make sense, if you can't run a full load, does it make sense to run multi-user testing to test the logic of multi-threading or the functionality? And what's the reality? What can you actually do to shift performance testing early in the cycle so developers can get fast feedback and be productive? And I feel like this question has been in the air for probably a good part of 2 years now, and it really needs to get an answer. And so the question that I'm proposing to this session is really, can you split it up? So if you think about our release, our SDLC, we design, then we code, we test, we build. There's a post-sprint testing, and then there's a deployment and production. So the traditional performance testing, looking at load testing of the service APIs, the delivery chain, and the backend, I think that stays in place. But the question is, can you add to the functional testing that's happening in sprint, maybe even per commit, can you add to that actual responsiveness testing of a single user on the client side? And if you could do that, can you then attach it to functional testing? And can you add sufficient information in there so that actually developers can start thinking about, oh, I'm downloading this large image to a small screen over a cellular interface, cellular connection, and I can do better. Or I'm doing the wrong order of processing and presenting things on the page. Can I optimize? So in other words, can you split it up into load testing that, in my view, has to continue happening a little bit later in the cycle when you have the environment to sustain load and reflect what a real production system would look like? And can you run responsiveness testing even per commit? By the way, this is a generic problem that can be looked at actually generically. So recently in a customer advisory role that I was part of, there was a notion of carving out what's possible out of big themes big testing things that are now happening post-sprint, can you carve those out and move some of that to the left? So there's a recognition that some things cannot be moved left. They have to happen manually. And because they have to happen manually, you can only do them. It only makes sense to do them when the application is mature enough in order to be close to build. But if you think about accessibility testing, you can, in fact, run accessibility testing, some of it even in Espresso and Xcode. Or security testing. You can do a build test with Jenkins, a static scan, and you can do that for every build, essentially. So you really can achieve early insight in Sprint in order to give the developers a chance to fix things and really give the team lead a chance to get to the end of the sprint much better ready from a quality perspective. And the nice thing is that if you do that, it really creates a single pane of application health between the operations people and developers. The operations people now know what testing has been accomplished before the next build is ready for production, and then developers are aware of what's happening in production, so they can get involved in production issues, or they can benchmark the next build specifically in terms of responsiveness against the application in production to see that I'm not reducing the quality in terms of performance. So let's think about single user performance testing and what could potentially be shifted left. So I call this responsiveness measurement. And what it is essentially taking an existing flow. I don't see people creating specific flows for performance testing, but rather creating an existing flow. And on top of that, adding a couple of elements. So for example, you can add OCR, optical character recognition, which is really automated eyes on the screen, if you will. So essentially measure the application load time, measure the login time, and so forth. So it really measures the rendering time, which if you think about it, when you put your username, password, and press login on any application, and then you do an OCR measurement, timing measurement on your bank account balance or whatever it might be, it's really the sum of all backend operations and all client-side operations. It really gives you the real, time of the application. In web, you also have W3C web page timers, both at the page level as well as the object level. You can do very nice analysis and trending and benchmark of the number of objects that come down, the sizes, the timing, and HTTP responses, and so on and so forth. You can govern the third-party service APIs, which servers and which geographies is your application trying to go to, and so forth. Particularly for progressive web apps and for responsive web apps, where you have one HTML code line for all kinds of screens and all kinds of network connections, it's really beneficial to do that kind of testing and comparison between different scenarios. And then consider responsiveness for script assertion policy. If you pass 3 or 5 seconds SLA, whatever your SLA might be, consider that for an assert. I think it's a legitimate assert to fail a script if you pass in smoke test, if you pass an SLA. And then, like I said, you can benchmark and trend. You can actually benchmark against the competition because you do this kind of testing from the user perspective, so you can do this against the competition. And one very nice, I would say, tool that's available out there is also film strip that enables you actually to do testing and see what is the user seeing over time. The other thing that I want to mention is BDD frameworks. BDD frameworks really help in enabling manual testers to upgrade their skills and write English-like statements to create scalable and robust scripts. And so as you can see to the bottom right, it's very easy to add a BDD statement to a script, which essentially says, after I search for the term Tom Brady on Google, I want to see the word Patriots, and I want to wait up to 3 seconds. In other words, if the word Patriots doesn't show within 3 seconds, that should fail the script. And then from a log perspective, of course, we want to give the developer and the tester sufficient information to find the root cause and optimize and correct issues. So it's definitely possible to offer a PCAP file or a HAR file. I'll talk about those in a second. Offer device vitals when we're talking about real devices, offer a crash log for native apps, and so on and so forth. So certainly, from a developer's perspective, there is a slew of tools that tell you what happens from a device over to the network perspective, a network log, as well as what's happening on the device at the operating system level, the usage of resources, as well as what's happening in the app in terms of the crash log. And lastly, you can then diversify your testing. You can consider real user conditions in terms of mobile networks, 3G, 2G, and so forth. You can look at resource-intensive apps that are running in the background. For example, if you're trying to access a Salesforce app or HBO, and in the background you've got a resource-intensive app, does that slow things down? Of course it does, and you want to be able to then, after you tested the ideal condition scenario, you want an environment that allows you to diversify your testing to include these real user conditions, because you don't want your users to find those issues in production. And so when you think about why is this valuable, why is all of this effort, why is this valuable? So firstly, you are able to leverage the developer's interest and trend around performance budgeting by giving them instant feedback. So when developers check in code, either if it's the commit level or the smoke level, within minutes they get insights about the functional testing, but they also can now get insights about the performance of their application. You spread the performance knowledge and analysis around the organization. There's no end of print surprises because it becomes an ongoing practice. And then you are able to embed performance knowledge and performance engineers inside the squad. And what you see with the maturity is that performance SLAs start showing up in sprint requirement stand-up and in sprint summary. So this is really creating a culture and a process where people are aware and are passionate about performance testing. So I wanted to dive in a little bit. So let's take a couple of examples. So this is an application from one of the fast food chains in the U.S. Essentially, it goes over, a flow in the application. It logs in and so forth. And you can see all the steps to the left and the video and so forth. What's interesting beyond the steps and the ability to measure actual timing, as you can see to the top left, the login time and so forth, you can see to the top right, what are the application launch, login, seeing the login page, and then logging in on the various different networks. And you can see that it actually is materially different. And those are things that you can control and can optimize, and I'll show in a minute how. In addition to that, you can measure the device vitals and actually the application utilization of vitals as the script goes on. And so you can see the two spikes when the application launches, and then at the login stage, you can see the growth of the network utilization and so forth. So these are good things to measure along with the script to find where are you consuming in time, what transactions are consuming a lot of data. One of the critical elements, naturally, beyond what's happening on the device and inside the application, of course, is the network connectivity. And so there are two assets that you can create. One is called a HAR file, HTTP archive file, which is essentially a summary, as you can see to the right, of all objects, their sizes, service APIs that are being called, the timing, the breakdown by, DNS lookup per object, content download, and all of those timings. How many calls, how many service APIs do you have open in parallel? What kind of sharding are you doing for the domains and so forth? So this is really a helpful HTTP layer log that really gives you insight about what's happening, between the application or website on devices and browsers and the backend. This is a log that is really friendly for developers because they live at the messaging level, at the HTTP level, rather than the lower layer. And so this is really helpful to see, for example, are you encoding usernames and passwords when you're submitting data? Are you compacting? Are you zipping information correctly when you're sending it? Are you opening the right set of ports? Is it the right order of operations? Are you connecting to a remote server, or are you getting a lot of redirects or service unavailable from service APIs? This is really helpful information. And then similar to that, there's a layer 2 PCAP file, which would give you packet level analysis, which would give you more than network engineers would be able to analyze retransmissions, packets that are broken, and so on and so forth. So you're able to actually point to a service API that gives you, for whatever reason, gives you bad information. Another tool that I want to recommend is naturally Google Lighthouse for progressive web apps and essentially any web app, which is really, really nice in terms of it gives you a film strip you can see with the timing, responsiveness analysis, performance analysis, opportunities for improvement, and so on and so forth. So really, this tool is really helpful, and I highly recommend it for web developers to look at it and utilize it in your testing. And then, of course, when you think about it, when you do functional plus responsiveness testing, as I mentioned earlier, you take the use cases and you add responsiveness testing on top of it, the OCR and so forth. You think about the platforms, but let's talk again about diversifying the testing. What is the application responsiveness when the user is in 2G, when Pandora is playing in the background, or in another tab, Chrome is checking the score continuously for another game, or the battery is at 8%. Are you able to add another dimension to your testing that considers these personas who are traveling, business travelers, or students in college with not so great reception, and so on and so forth? Okay, great. So I hope this makes sense so far. We're going to dive into a demo, and after the demo, we're going to come back and conclude.
Cool. So in terms of the demo, what I have here is a basic Appium script. You can see that, I am looking at the Netflix mobile application. Essentially, initially, I'm closing the application to make sure that I'm starting from a known point. And then I'm adding a command to start collecting the vitals from the device, as well as simulate a 3G network and collect the HAR file. At this point, I'm launching the app and I'm doing a visual OCR checkpoint for the word offline. You'll see this in a minute, placing a threshold of 99 and a timeout of 30 seconds. And due to the fact that I'm doing an OCR, I can actually collect the measurement of the timer that it takes the application to launch. And so from here, I'm traversing through, I'm clicking on sign in, and again, doing a text checkpoint. This is a good thing to do, not only from a performance perspective, but also from a script stability, just to make sure that you're clicking on something and then that thing actually, an anticipated response shows up. Logging into Netflix, I'm putting in my email and password and logging in. And again, I'm checking that, the desired result is showing up, and I'm measuring the time for that. And so forth. I'm going to traverse through content. I'm going to look for a series, and then I'm going to log out. So let me run this quickly so you can see. So on the right here, you should be able to see a mobile device open up. And by the way, the same practices are going to actually appear for both web, Android, iOS devices, tablets, devices, and so forth. And so this is starting to run. So now the application is running, launching right now. I'm going through the sign in stage. I'm looking for the word offline visually. Going to put in my username and password. You'll notice that the launch time is 2.5 seconds. And it's now logging in. And I'm going to be able, so here the login time was 4.6 seconds. I'm now going to look for content, and eventually I'm going to log out. Let's take a look at the report that's being created for us. So you can see here the device that we've been using, and all the commands, all the steps that we've been taking. And what's interesting here is that, again, we start the vitals collection, we start the network virtualization. You can see that this is the 3G network profile and the HAR file that I'm using. And then I'm launching the application and I'm doing a checkpoint on the word offline, which shows exactly here. And it takes, as you can see, 2 seconds, 300 milliseconds to load. And so here we traverse through the different stages of the application, etc., etc. Naturally, I can also see a video of the application, etc. So here, what I can also do, in addition to downloading the report and everything, I can actually download the network file as well as download the vitals. And when I look at the network file, for example, the HAR file, which is essentially a very long JSON of all the interaction, what you can see if you open it using tools like any HAR viewer that's available online, you can indeed see all of the interaction between the application and the backend, the various servers' responses, the sizes of the different requests, and the different operation over time. And within every one of those operations, you can see the headers, the parameters, and the response. So this is very helpful, for a developer, for network engineers, and so forth, backend engineer, to really understand the optimization of their website, of their mobile application, and so forth, in order to optimize in real time. If you can bring this type of data to a developer really quickly, and if you can maybe even trend this over time and put in asserts based on the application SLA, or for example, if you set the SLA for application launch time at a certain thresholds, or I think in this case, we looked at logging into the application, and in this case it was a little over 3 seconds. If you decided that the acceptable SLA for application login was 3 seconds, you could in fact set an assertion in the script for 3 seconds and fail the scripts, and then direct the developer attention to the time that was measured, which is in the report that's in their hand, and then show them the vitals, show them the log files, show them the HAR file, and so forth. So these are a set of elements that are really helpful for developers and allow you to conduct testing that takes into consideration performance in sprint, as we discussed.
Cool. So hopefully this demo was beneficial. And again, we want to go back to the different aspects of performance testing. And I cynically is asking, is load testing dead to me? So the answer is absolutely not. Absolutely not. It's what I'm representing here. Responsiveness testing and load testing are two complementary practices that really are looking at two different aspects of your application. And really what I think needs to happen is the responsiveness testing is an opportunity to shift left into the sprint, but load testing, including real devices and browsers, really is something that needs to happen as well. And so when you're doing this, you can conduct load testing on the service APIs, as well as run scripts on both the service APIs, but also run scripts on real devices and browsers, and chart the responsiveness from all of those at the same time. So you can see to the top right an interesting chart that shows, the background colors is the load and the responsiveness of the web assets, but the different lines here, and specifically the spike here, are coming from devices and browsers. So that's another interesting aspect of this methodology. Cool. So to summarize, like we said, for the team lead, complexity and compliance requirements and responsiveness and performance of the application and availability eventually are really rising. and the time they have and the dollars they have and the resources they have typically are shrinking. They need to do much more with much less. And so what are the opportunities with responsiveness testing? So firstly, try to split, what can you run earlier? What can you embed into the sprint? Consult with developers, consult with the team leads. If I can run something, does it offer value? You don't want to run something just for fun. You clearly want to invest in something that's going to deliver value and really deliver value for developers. And then you define the single user performance test, embed that into the agile process, and make sure that it's automated, it doesn't add flakiness to the test, and it provides value. So, and then lastly, run that as a process naturally, create that culture, and then at the end of the sprint, also add responsiveness to the load test. And then, of course, over time, track, benchmark, communicate, highlight your achievements, and hopefully this will create more awareness and more cultural advancement of the performance agenda. So hopefully this was beneficial for everybody. Thank you, Neotis, for hosting me on this virtual conference. Please feel free to follow me at my Twitter, Amir_Rozenberg. I do have a GitHub repo under Amir at Perfecto, so Amir at Perfecto, and definitely looking for your feedback and questions and so forth.